This is my Shiny app to help do descriptive and inferential statistics. This can help you to tell a story through statistical tests and data visualizations from these four tabs above. We have a data tab that allows you to get in the data or save the data that you want to use. We have a describe tab that does some descriptive statistics, allows you to plot various graphs to show more about trends and differences. And next we have the power tab, and that is a tab that does distribution tests as well as power analyses. And then we have the 95% confidence interval tab that lets you look at differences between groups and differences in trends between groups over time. So in the data tab we have different sections. The first one is a text box that allows you to enter your data frame. For anything you do in this Shiny app, you're going to first want to enter your data frame name here, and that'll load the data for all the other tabs and subsequent sections. And below that, if you want to take a look at the data, you click that button to yes, and that gives you a view of your first 10 rows of data. Below that, we have an option to upload our data if you already have data saved. And then below that is the name of that data frame that's been loaded. You can copy that and load it into the text box at the very top. We also have a section if you want to upload data from text files such as a CSV or tab delimited file. You load your text file here. You select it, click open, and if you want to analyze that data directly to use it for those other tabs, you could click yes. In step 4 and 5, it gives you the option of saving your data. And if after you name the data and click yes to number 5, you can save your data. For anytime you save data in this Shiny app, you want to end it with the extension .r.data, and then you give it a name and save it that way. Below that, if you don't want to just immediately save that text file into an R data file, but if you need to modify it anyway, you can do that here. One of the things we often need to do is create time formats for our date variables, and these are all the various options of different date formats that you can use. And again, you go through the options and you can load or you can save that data frame here. Always remember to put .rdata at the very end before you save, so it'll get saved as an R data frame. And now we'll look at the Describe tab. I have what's called a calculator grapher. You can do things such as adding 3 plus 3, 9 times 9, but this calculator grapher does a lot more than work as a calculator. You can also add in your own code if you want here. This tells us the percentiles for different ages from the Titanic data. If you select no, you get no results. If you click results, you get the results from a calculation. But if you also want to graph something, you have an option to graph it there. And then below this we have we can enter in specific variables to get different descriptives, such as a summary, which has a 5-number summary plus the mean. We can also see what the standard deviation is and the coefficient of variation, and you just select and run that. And then below that we have an option to run a histogram. We can do it for one variable or we can do it for that variable but spread over by factor levels. So in this case, we want to get the percent of inpatients with COVID, and we want to compare it by different regions in the US. You can do color options and other options within here. There's over 50 colors to choose from. Everything from your standard red, orange, yellow, green, blue, purple, and so on, to very specific colors such as cyan, or there's even a color named Dodger blue. So there's a wide variety of colors to choose from. And this gives us the histograms per region. Below is a very helpful tool to explore the mean values of an outcome by factor levels. This is a very, when we analyze data, one of the first things we want to do is look at the descriptives. For continuous variables such as percent of inpatients with COVID, it breaks it up into quartiles. And then we can see how the percent is associated with COVID deaths above. So what we're looking at up top is a linear trend that as the number of inpatients go up, so do the number of deaths. And we can also look at differences between region, month, which is almost a linear trend. And then below this we have scatter plots. We select these different settings, and what we're looking at is a correlation of critical staffing shortages per day on inpatient beds used at COVID. And these are two continuous variables, but you can also have an ordinal or even categorical level on one of these axes. We do get a correlation test, which we can see here is significant because the p-value is less than 0.05, and we do see that the actual correlation is moderate. It's at 0.6. So it's not a flat correlation between these two variables. We get the test results here. Below the scatter plot, we have a similar test that allows us to stratify by a factor. So again, we're looking at critical staffing shortage. Yes, the association or correlation with inpatient beds used for COVID. But now we're going to look at different groups. We're going to look at Western states, which is the West Coast and the Southwest combined, and we're going to compare them to non-Western states. And we see that in this red line that Western states do have a stronger correlation than non-Western states. And then we have trends over time by groups. So this lets us see what that distribution looks like over time. We're going to start this. This has a play option, so it runs like a flip book. And this gives us an idea of what the distribution looks like. So we'll hit play. We see in the beginning, inpatient bed utilization is spread, but over time we're seeing it go up, and we're also seeing a tighter distribution. So that means across the U.S., over time, more and more states were using more of their inpatient beds, and it's increased from about less than 50% to over 73%. We can put it in a blue target line here. We have that option above, and below that we can see each of these different means over time. These numbers change each time that moves across. So we're looking at the last time point in the data, and we also get how many above or below that target. And we can do something similar to what we did above, a couple parts above, where we can see we can look at missing values. Oftentimes it's very helpful to look at missing data, because something that prevented us from getting that data might tell us more about that outcome. So we see how much it is for a variable of interest such as inpatient beds. And below that we get the proportion of missing for each variable in our data set. So now we go to the Power tab. We can do proportion tests. We can do t-tests. For example, we looked at high bed utilization, comparing the West and non-Western states, and we see that the non-Western states actually go higher number of days, have more days where they have a high bed utilization compared to the Western states, which is at 0.33. We have similar t-tests, but instead we're looking at continuous outcomes. And for here, it's the number of deaths from COVID. This is not significant, close but not significant, with Western states having more average deaths in hospitals per day. Then we also have what are called power analyses. And those give us an idea of how big a sample we need in a statistical test for it to have an adequate amount of power, or how much power we had in a test. And then below that we have what are called effect sizes. With statistical tests, it's impacted by the size of your sample, so the bigger your sample is, the easier it is for it to become significant, statistically significant. Effect sizes don't take into account the sample size. So what's helpful about that is it gives you an idea of, is this a big effect, a medium effect, or a small effect? We might see a very tiny effect that's significant, but we should also consider if that's a big effect or not. Then we also have 95% confidence intervals. This top one allows you to look at an outcome by a factor. For example, here we're looking at the deaths from COVID, and we're looking at it, we're comparing different regions. We can look at it, we can sort these different regions alphabetically. For example, it starts at the Midwest and goes down to the West, or we can sort it numerically, which shows us the lowest value to the highest value. These values are found below. Also, we have an analysis of variance. Above, I have it set to a t-test, but we can also do a proportion test or Poisson test if appropriate. But it gives us an analysis of variance for a t-test and a Poisson distribution, or a Poisson test, and it also does proportion test for proportion outcomes. So these distribution tests just give us an idea of if one group is significantly different from another group. But if we often want to know if these pairwise comparisons are significant or not. So that information is found here. And lastly, we have trend plots that give us an idea about the same types of tests we looked at before, differences between groups, but in this case we're looking at it for each time point. And so here we have kind of a harder to read straight line plot, so we're going to switch it to a smooth curve plot. We change this to answer to no. It converts that over for us. We can see a lot of, as we did with the that flip book in the Describe tab, we can see a lot of distribution in the beginning. This is January 2020, or I'm sorry, this first green bar is March 2020. We're seeing a lot of variation here for inpatient bed utilization. Over time, that utilization goes up and gets into a tighter distribution, And at the second green bar, we see that tighter distribution at January 2020. It's leveling off after in our most recent month, but we do see that we're at a higher, we're utilizing beds more than we did back over a year ago. And so these values are listed below. They do have the 95% confidence interval. So let me show you the bands. It's kind of harder to see, but we can just name it, get specific groups. Click that there, and then we can identify different plots. We can show everybody or show specific ones, and all of those values are listed below here for each different state, and we can do the overall average for the entire country. So these 4 tabs should allow you to get an idea of what's happening in your data, and show you and provide graphs and results that can help you explain that.